So in the last class, we started the MOT, and I was telling you, if you have the one hydrogen, like whenever you are making the molecule, so how we have to fill the electrons and what would be the series. See, hydrogen, they are going to combine so that they will become the noble gas configuration, right? Because this is one hydrogen, this is another hydrogen. So when both the hydrogen will combine, so they will have a duet, na? They will
Yeah.
complete their duet. So both will be happy. So if both will be happy, that's why they are going to form the molecule. So this is
Mhm.
hydrogen one and this is also hydrogen one. Okay.
Yeah.
So actually here, whenever molecules are going to combine, na, so Vishnu, I
Mhm.
told you there is a bonding and there is a anti-bonding.
Yeah.
So when this one and this one they are combined, so it is called bonding. But when this one and this one is going to combine, it is called anti-bonding.
Okay.
So bonding has a low energy. Low energy means stability. So this is the
Mhm.
bonding orbital. See, it
Mhm.
has a 1s1. It also has a 1s1. So this is the 1s1 bonding. 1s sigma 1s1 bonding. And anti-bonding
What?
has a high energy. That's why we are making it above.
Oh.
This is the anti-bonding orbital.
Yeah.
So this is the bonding lower side and upper side is the anti-bonding. So for the anti-bonding, you will show like sigma star. Star means anti-bonding. This is how you have to show. Okay. So
Mhm.
this is the reference line at the middle, like normal energy. But when they are going to form the molecule, so it is split. So orbitals is split. So one orbital is bonding orbital. Bonding is always the lower side. Why
Yeah.
lower side? Because energy keeps on increasing like this.
Mhm.
This is showing you the energy. तो ऊपर की एनर्जी ज्यादा है, तो अपर एनर्जी इज हायर, लोअर एनर्जी आई मीन लोअर साइड इज अ लो एनर्जी, and low energy in the chemistry means stability.
Oh,
Okay.
okay. Yeah, yeah,
So
I see.
so in the chemistry, if you have the low energy, then it's a good thing in terms of like you have the, I mean you are the stable one.
Mhm.
Okay.
Lower energy means stability. Okay, got it. I got it.
Okay. So one electron is coming. Actually, every electron want to go to the bonding side. Every electron want to go to the stability side. So this electron is coming over here and it is going. See, Vishnu, when they are going to form the molecule, so this one electron is coming out and it is going into the bonding. So in a one room, two electrons are allowed, right?
Yes, in one S
So
room.
one electron is going this side and this electron is also want to go this side. So it is
Mhm.
asking, can I come with you? So it is saying, of course, why not? Because there are two availability. So yes, so both the electron will remove from here and they will enter into this, right?
Yeah, because they have lower energy.
So any other electron will go into the antibonding.
Because it's filled. Because the
No,
one is no.
no
Because the one.
electron is going into the antibonding because both the electron are already filled in the in this one. So there is no
Yeah.
need to fill up the antibonding, right? So if I
Yeah.
ask you one thing, in the hydrogen molecule, how many electrons are there in the bonding orbital?
Oh, one.
Array two. One from this hydrogen, one from this hydrogen.
Oh, an H2. I thought you said H. Okay.
No, no, no. H2, H2.
Oh,
It
H2.
is the
Then it's two.
it is the molecule formation. So one electron is coming over here, one electron is coming over here, and it is going into the bonding orbital. So both the
Oh,
electron are filled in the bonding because they are making a molecule now.
I
And
thought you
how
meant
many?
like. I thought you meant in a single hydrogen atom. How many electrons are there in the
It
orbital?
is already one. But when they are going to make a molecule like hydrogen gas, H2, so both the electron are entering into the bonding orbital because bonding is stable.
Mm-hmm.
So no one is entering into the
Got it.
No one is entering into the anti-bonding one. Got it?
Mm-hmm.
Okay. So, fine. Vishnu, one day I told you, okay, suppose if I say helium, suppose helium is also making the molecule. Obviously, you know, there is like helium will not make any molecule, right?
Mm-hmm.
But still, suppose it is making some molecule, right? So if it is making some molecule, so can we say helium 2? So
Yeah.
obviously helium is 1s2 and other helium is also 1s2,
How does
right?
that? They don't bond, do they?
What?
They don't bond because they're oxygen.
I know it is a hypothetical case I am taking just to teach you,
Ah, I see.
just to tell you how things happening here.
Got
It
it.
is 1s2, it is 1s2, right? So I
Mm-hmm.
told you now, like if it is a one helium, it is a other helium. So they are
Mm-hmm.
at the reference level. So
Yeah.
obviously, like these two electrons, they will split up the energy. Lower
Mm-hmm.
side, it is a bonding or anti-bonding.
Lower side is bonding. Higher side is
Very
anti-bonding.
good.
It has
So
more
if we
energy.
will say sigma bonding 1s,
Yeah, yeah, yeah.
right? Sigma bonding 1s. And
Mm-hmm.
upper side,
Is anti-bonding.
yes, it is the anti. So we will say sigma anti-bonding 1s, right?
Yeah.
But I told you whenever they make a bond, so both the electrons should remove. So two electrons are getting removed and they are going in the bonding one, right?
Mm-hmm.
So these two electrons are coming and they are entering into this. Okay, done. Now these two electrons are coming over here. These two electrons are coming over here and they are asking, can we come? So it is becoming very angry. No, you are not allowed to come. Why? Because we are already filled. Just go to the other side. So now these two electron has to go upper side, yes or no?
Mm-hmm.
Majburi hai na, they has to go. They have to go actually.
They have to go up because
Yeah. So like this. So it means complete. So it means how many electrons are there in the bonding?
total.
Total how many in the bonding orbital,
Oh, two,
and in the anti-bonding.
two. So it's four
So
total.
it is completely filled or anything is vacant?
No, there's no vacancy. They're all filled.
There is a vacancy.
No, there's no vacancy.
Yeah, there is no vacancy, and whenever you see there is no vacancy and everything is paired, so you will say these material are the diamagnetic.
Yeah.
Diamagnetic means like it is weakly, like it is a kind of like weakly repelled, okay, from the magnetic field,
Mm-hmm.
right?
Yeah.
So what is the meaning of diamagnetic? When it is weakly repelled, weakly repelled. And what is the meaning of paramagnetic? When it is weakly attracted. So if you see any unpaired electron or any vacant, like if something is not paired, so you will say it is a paramagnetic. But
Mm-hmm.
if everything is paired, then you will say it is a diamagnetic, right?
Yep.
So I told you there is a sigma 1s, sigma anti-bonding 1s, okay? So
Mm-hmm.
same thing we can't do every time like this. Like
Mm-hmm.
if I tell you now for the p, suppose if I have anything which have a p orbital. So p orbital also further break down. Like you know it, p means there are three orbital na.
Yeah.
So if any molecule which have, like if I say nitrogen molecule N2 gas. So N2 has 1s, 2s, 2p, 2p. So p has three orbital like this.
Yeah.
There is one nitrogen, there is another nitrogen. But these three orbital, there is a name. I told you. I told you if you remember that. Like X and Y, they make a pi bond, like pi 2py and pi 2px. Actually, they form always pi bond. And Z वाला जो होता है, Z is forming always sigma bond. Okay. So
Mm-hmm.
these three orbitals have the name. Fine. Same thing
Yeah.
here. So when they make a bond, so obviously their energy is split. So whenever their energy is split na, so always remember Vishnu, always
Mm-hmm.
remember like the pi one, I'm saying this pi is the more stable one. So that's why 2px is equal to pi 2py. They are at the lower side. Why? Because they are the most stable one. So they have the low energy. And if I talk about the sigma 2pz, so it is a little bit above. Why? Because sigma 2pz has the little high energy.
Wait, what is 2px and 2py? I don't understand. Is that each
These
room?
are the like initially when I told you 1s. So 1s, it is the name of orbital 1s.
Oh yeah, yeah, I get it now. I get it
So
now. I
it
get it
is
now.
the name of orbital. Okay, three
But
box,
why are
pi.
they in? Why isn't? Why isn't? Why isn't X on the left? 2px on the left.
Oh, just do it. If you have confusion,
Oh,
do
does
it.
it matter which one it is, or does it not
Yeah,
matter?
yeah, you can do and you can take anything. But you
Oh,
should remember, x orbital, which is in the x-axis. So it always forms sigma bond because it is end-to-end overlapping.
okay, got it.
And the rest of the x and y one, they always form the sideways overlapping. That's why it is pi. It is fixed.
And then Z forms the sigma bond, but not the pi
Yes,
bond.
always, always. And it has a little high energy. That's why they are above than the pi.
So sigma bonds have more energy than pi bonds, right?
Ah, yeah. Sorry, sorry. Yes.
Oh, actually, okay, that makes more sense. That's why it's above.
So it has all these are the bonding one, right?
Yeah, yeah, yeah.
All these are the bonding. So
How about
obviously,
the anti-bonding?
so they have anti-bonding as well.
Yeah.
So this is how we have to. I know this theory is a little typical. I know, but
Yeah, no,
not.
I think it's okay.
So here now you have to make sigma 2p z here, sigma 2p z anti-bonding, and
Mm-hmm.
this one anti-bonding have the high energy like this pi 2p x is equal to sigma anti-bonding 2py. So these are the bonding one and these are the anti-bonding one. Okay.
Mm-hmm.
So when you fill up the electrons of nitrogen, so can you just tell me where the electron will first go? If electrons are removing from here, and so where it will go? Bonding or anti-bonding?
Which one? It's gonna go to bonding.
Suppose three electrons are here and three
Yeah.
electrons are here. Okay. So
Okay.
these three electron will go which side, above or down?
Down.
Okay. And out of down, it is like at the bottom or little bit above.
Bottom, right?
Yeah. So firstly, you will fill the pi 2px, pi 2py now.
Yeah, but wouldn't they be like half filled, but all of them?
Yeah. You can do. Actually, there are six are coming now. So two are filled
Oh,
here,
yeah,
two
yeah,
are
yeah,
filled
yeah.
here, and
And then
and
one is
and
filled
and,
above.
and then they will go to the px. Okay. So all
Yeah.
six are filled.
Mm-hmm.
So any other electron is left which can go to the antibonding?
No.
No, all are filled. Okay.
Yeah, yeah.
But
I get it.
suppose,
I get it
but
now.
suppose,
There was
suppose,
six. If there was six on each side, then yes.
yeah. No. Yeah, you are right. But suppose I am giving you the 4 and 4. Then,
Mm-hmm.
so 4 and 4, it means six are already filled here.
Mm-hmm.
Out of like 4 and 4, it is total eight, na? So out of eight, six are already filled in the bonding.
Yeah.
So how many are going in the anti-bonding?
Uh, three. No. Wait, hold on.
Two na.
It's two. Because it's
out
six.
of out of
Eight
eight,
minus six
six
is
are
two.
already filled, so it is only two are left. So
Yeah, yeah.
obviously these two will go this sigma 2pz anti-bonding, yeah, above side.
Two will go to the above side. Yeah.
No, we always have to fix energy wise, so it has lower
Yeah.
energy na
The
as
two
compared to
PZ. Two
this.
PZ. Sigma bonding first.
2pz, 2pz, sigma antibonding 2pz. Okay.
Yeah.
And then if you have extra electron, then they will go this side.
Yeah.
Okay, fine.
Got it. Got it. Got it.
Okay. And one more thing. Actually, this pi 2px and this pi 2py, they have the same energy, na? So that's why you, whenever you have two electrons, so first try to fill electron one and one, because both have equal right. You can't directly fill two electrons this side and no electron this side. No, 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 no. If it is one, then fill here. If there are two electrons, so fill one and one. Okay,
Mm-hmm.
because they have both energy, so share would be equal.
Yeah.
Okay, so actually, filling up electron by making such a diagram, it is really difficult. So that's why we have made out a series. Okay, and by using this series, you don't have to draw these structure. You just need to learn the series, and then you can do anything. Okay,
Mm-hmm.
so you have this series. I will tell you how we have to fill it. Don't worry. Sigma 1s is the lowest one because it is always downward. And then sigma anti-bonding 1s. Then
Yeah.
sigma 2s. Then sigma anti-bonding 2s. Then I told you there is a pi, na? And pi have the same energy. Remember?
Yeah.
I told you, see, if P is started now, so if P is started here, so the pi 2px and 2py, they have same energy, and then 2 sigma 2pz.
Yeah.
So sigma 2px is equal to, oh sorry, pi 2px
2py.
is 2py.
And
And then
then
there is a
2pz.
sigma 2pz. Okay. After
Yeah.
that, we will enter into the anti-bonding. So
Yes.
sigma,
No.
uh, uh,
2pz.
sigma 2pz anti-bonding,
Oh,
and
that's it.
anti-bonding is must.
Yeah. Pi 2pz equals
Pi
pi 2py.
anti-bonding 2px,
Yeah. Yeah. That's what I said.
pi anti-bonding
Anti-bonding.
2py, right?
Yeah. Yeah.
So,
That's correct.
so
Yeah.
this series you have to remember.
Yeah.
But remember, okay, fine. Suppose if I say you have to fill up the electron for the hydrogen, helium, lithium. Suppose if I'm saying, so let's suppose I'm saying lithium 2. Suppose. So how will you fill the electron? See, I'm telling you. For lithium, one lithium contain how many electron?
But one lithium contains 3 electrons.
So two lithium contain how many electron?
6.
Are you sure?
Sure.
Okay. So now fill up the electron. 6 electrons. So sigma 1s, it contain only 2. Sigma antibonding 2. Sigma 2s 2. Right? So 6 electron
Mhm.
are done.
Yeah.
Bus done. It is the molecular orbital theory. And remember, there is a one term which is called bond order. This bond order is equal to half bonding electron minus anti-bonding electron. Actually, this bond order helps us to know the stability and to know the length of the bond. So suppose if there are 5 molecules and I'm asking which one is stable. So whichever molecule has the higher bond order, that is the most stable. Okay. So just
Hmm.
tell me, for the lithium 2, it is a 6 now. So how many bonding electron are there? How many bonding electrons? These are the
Three.
bonding electrons
Oh,
now.
this is 4.
So 4 electron. How many anti-bonding electron?
1 or 2.
2. So what would be the answer? 4 minus 2, 2,
1.
2, 2, 1, 2, 1, right?
Yeah.
This is the bond order of lithium.
Mm-hmm.
Got it?
Yep.
Are you sure?
Got it. Yeah.
Okay. So suppose if I'm saying I have the nitrogen. Nitrogen is N2. So can you try to fill up the electrons?
Mm-hmm. Of N2.
Yes, N2. I'm just erasing that.
Don't erase the blue stuff, please.
Oh,
Wait, so it's 1 minus the one above, right?
what? What you
The
said?
bond. Yeah, it's just 1/2 time brackets
Bond order, yes, I'm writing. Bond order is equal to half bonding electrons total minus
minus non.
anti-bonding electrons.
Yeah. Because I thought that looks like beryllium to me. Be. I don't know.
Bonding electron and anti-bonding electron.
Yeah, got it. Okay, so N2 has, what is it?
One
6.
nitrogen contains 7 electron.
What? Oh, yeah. So N2 contains 7 electrons, right? So 7 electrons. So it's 1s done. 1s. Okay, wait. Is 1s bonding? 2s bonding done. 1s2, 2s2, 2p3. Wait, N2 bonding order? Do 1/2 into 14 electrons, right? No. Is it 3?
Are you sure?
Yeah, I think so.
Okay, let me help you.
I don't think I'm right.
Oh, okay, you're not confident.
I'm not
See,
confident now.
one nitrogen contains 7 electrons, so two nitrogen contain how many? 14 electron, right?
14, yeah.
Okay, so fill up the 14 electron in the above series. 2
1s?
electron this. Sigma antibonding to 1s2. Sigma 2s2. Sigma antibonding to 2s2.
Yeah.
PP. These all are the orbitals. So one orbital contains 2 electron only. So you have to fill, see, 8 electrons. So 2 and 2 equal you have to do. If it is 2, then you have to fill the 1. But yes, you have the sufficient. 2, 2, 2, 2, 2. Total how many electrons become?
12. You need one
12.
more.
So we have to fill 2 more, right?
Yeah.
Now it is done 14.
Mm-hmm.
So there is no need of this one.
So it's 10 minus 4, right?
So half, how many bonding? This one is
10.
bonding, this one is
10.
bonding,
10.
this one is bonding. So 2, 2, 2, 2, 2. Oh, it is 10.
Oh,
And
I got it right.
anti-bonding are only 4 upon
Yeah.
me. 2.
I
Oh,
got it
sorry.
right.
Oh, sorry. So 10 minus 4, it is 6. 6 by 2, it is equal to 3. Yes. So bonding is 3. Got it?
Yeah.
Are you sure?
Yeah.
Okay. So this is how you have, okay. So it is the N2 now. Suppose if I have said to you N2 2 plus. Do you know what is the meaning of N2 2 plus? N2 2
Yeah.
plus means it has lose its 2 electron to anywhere else. So now N2
Yeah.
2 plus has how many electron total?
5. Oh, no,
Eh,
12. 12.
12. Yes. So can you just remove the last two electrons? Last one.
2p2, so it's 8 minus 4.
Sigma 2pz you can remove.
Yes, it's just 2 then. It's just 2. It's
Yes.
bond order
So,
is 2.
hey?
Bond order is 2.
Okay, border is 2. Okay, let me check that.
8
So
minus 4.
if it is 12, तो इसका मतलब हमें इसे भरने की जरूरत ही नहीं पड़ती. We don't need to fill that. So it
Yeah.
means how many bonding? 1, 2, 2, 2, 2. So it means it is 8, 8 minus 4. 8 minus 4 is 4 and 4 divided by 2. So your answer is 2, right?
Yeah.
So just tell me, out of N2 and out of N2 2 plus, which one is more stable?
N2 2 plus.
I told you, more the bond order, more is the stability.
What? No, you didn't.
I told you. Okay,
When?
okay, fine. More is the bond order, then more is the stability. Okay.
I thought you said less number of electrons is more stable, right?
No, I told you less energy than stable. That was the different thing.
Oh.
And it is the new different thing. If your bond order is higher, then your atom stability is also higher. I told you about the energy. If you have less energy, then you are stable. That is the different thing, and it is done. Now I am saying another thing. If bond order is higher, then stability is also higher.
Got it.
So which one is more stable?
N2.
Yes. But there is a twist actually.
Yeah.
And what is that twist? Actually, this series is only applicable up to 14. My God. Afsos. This series is only applicable to 14. If you have anything which has more than 14 electron now, so little bit change you have to do.
Yeah.
And what is that little bit change? Little bit change is this is sigma 2pz. When you have the more than 14 electron now, so it has like more stability. That's why it will come here.
Mm-hmm.
Okay. So and this one sigma antibonding, it will go back. Okay,
Yeah.
I'm helping you. I'm helping you. Everything remains the same. Only two things will get changed. Okay.
Yep.
Can I rub this?
Hmm. Yeah. Yeah.
This is a molecular orbital theory, and this is considered as a toughest theory. Okay, if you are understanding, then it's really good. So up to 14, you will apply this theory. But if your molecule having more than 14 electrons, oh sorry, I just put the wrong arrow. Less than less than 14 and equal to 14. But if you have the more than 14 electron, then everything will remain the same, only little bit difference, right?
Yeah.
Sigma 1s,
Mm-hmm.
sigma anti-bonding 1s, sigma
Yeah.
2s, sigma anti-bonding 2s, sigma.
No, it's pi.
Yeah, no. I told you, little bit difference.
Oh.
So 2pz सबसे पहले आ जाएगा ना, I told you. Remember?
Mm-hmm.
Pi 2px is equal to pi 2py.
Got it.
पाई पाई वाले आसपास आ जाते हैं, मतलब पाई एंड पाई दे कम क्लोजर. So pi anti bonding will come closer.
Mm-hmm.
It is actually just a little bit shifting if you have more than 14 electrons.
Yeah.
Okay, this will go back and this will go in front.
Yes.
So this is the more than 14. Are you sure?
Mm-hmm.
So suppose if I have said to you, you have the oxygen.
16.
So which series you will apply, first or second?
The second one, because that's 16, not 14.
So can you just tell me the bond order for the oxygen?
Yeah. One sec. Okay, so it's 2, and then 2, 2, 2, 2. Okay. So this is non-bonding. Non-bonding. Okay, so it's 10 minus 6. It's 4. No, it's 2. It's 2.
Should I lock it?
Yeah, 2 is my final answer.
Absolutely right. Well
Yeah, I
done.
know. I know.
Yes. So it is like oxygen is 16 na, O2, 16,
Yeah.
8 and 8. So 2, 2,
Yeah.
2, 2, 2, 2, 2. How
Mhm.
many? This 14 are done. 14.
Oh,
So
yeah,
if
yeah.
14 are done, we have to fill only 2 na,
Mhm.
and both are equal. So
Yeah.
we have to put 2 or we have to put 1, 1.
2.
No, by chance you are right. But actually, I told you if they have same energy, so you have to put 1 and 1.
Oh, yeah, yeah.
Remember?
That's right.
Okay, but yes, both are anti-bonding. That's why your answer is also right.
Yeah.
But actual trend is you have to fill half half.
Okay. I
Okay.
guess that makes sense. But that's only for anti-bonding, right? Not for bonding.
Yes, yes, yes.
Got it.
So half
Got it.
bonding means 2, 2, 2, 2, 2. These are the bonding. So it
Yes.
becomes 10.
Yeah, yeah.
And anti-bonding are obviously out of 16. So 10 are bonding, so 6 are anti-bonding.
Yeah.
So what would be the 10 minus 6? 4. 4 by 2, it is equal to 2. Am I right?
Yeah.
So this is, Vishnu, if I have said to you O2 minus, O2 plus, O plus, so can you find out for the same?
Yeah.
Of course. See, if I have said to you O2 2 minus, O2 2 minus, so it means how many electron it has total?
It's 14. Oh, no, it's
Hey,
18.
18 because 2 minus means 2 are getting added
Yeah, I
and
caught
2
my
plus
mistake
means
there.
it has loose. Okay, so it is your homework. It is your homework. Like you have to find out the bond order and find out the stability, which one is more stable. Okay, like
Got it.
O2, O2 2 minus, O2 2 plus, and O2 plus. Okay, and O2 minus. So you have to arrange according to stability. Okay.
Yeah.
Are you sure? Just take a screenshot of that because it is very important.
One sec. Let me take a screenshot.
Because it is the series for 14 plus, it is the series under the 40 and 40. Got it?
Got it. Yeah.
Okay, so it's all for the today. We'll meet in the next class. Bye bye. Take care. See you.
Bye. Thank you.
Okay, bye bye.